Okay, so so today we are basically doing two-dimensional momentum. Umaid, are you aware of vectors? All right. So first of all, let me tell you what basically I mean. For example, you have an object that was moving at a velocity 1, it had a mass m1. What? एक सेकंड, ये क्या हुआ? इंटरनेट बंद कर दिए, बाहर भी क्या किया? Okay, you guys can hear me? Hello.
Yes.
Okay, I'm sorry. I think my connection was interrupted for some reason. Go back.
Yes, sir, it's better now.
Okay, it's cool. All right. Ramin, long time no see. Why?
Sorry, sir, my school started and I've been busy in that, but now I'm back.
Okay, I hope you will be regular as well. Okay.
Yes, I will.
All right. So basically, in two-dimensional momentum, I just want to tell you. Suppose this is m1, that's u1, and there's another object. Alhamdulillah, sorry. And this is m2, and this is going at u2. So this is what is happening before, and afterwards when they collide, right? So one goes to this side, m1 with a velocity v1, like this. Uh-oh. I should have, made it like this. And one goes to this side. Should make it, doesn't look nice this way. I think I should make it like this, then v1, m1, and the other one goes like this, m2 with the velocity of v2. And of course they will have certain, angles between them. So let's call this theta, let's call this alpha. Okay, now this calls for vectors because the reason is that this is two-dimensional, right? It's going that way. So I just want to tell you something important, and the note to basically write here is that always apply law of conservation of momentum in each dimension separately. That's what you got to do. what I'm going to do is I'm going to make two headings, one for horizontal and the other for vertical. So for horizontal, I would like to tell you that this vector, that's the v1 vector, basically it will have two components, one on the right, one upwards, and for the v2 it will be one towards the right and one downwards, like this. Now what it applies the same rules of vectors. For this one, as you can see, it is next to the angle, this vector. So this is going to be m1 v1 cos theta, and that one would be m1 v1. Now what you're going to do next is you're going to write the vectors for the other one. So 1 m2 v2 sine of alpha. Now if I say, okay, I'm going to take this side as positive, this side as negative, right as positive, left as negative, then this means then this is going to be positive, this is going to be positive, this is going to be positive, and this is going to be negative, and these two are also positive. Is it clear, everybody? Okay.
Yes.
All right. Please let me know if I don't know what what has gotten into my internet. Do let me know, okay? My voice is breaking. Okay, now. So for horizontal, I would just look at the horizontal vectors. So I'm going to write before equals after. So before they were both horizontal, it means m1 u1 plus m2 u2 was equal to, now the horizontal vectors are m1 v1 cos theta plus m2 v2 cos alpha, right? Understood? Now, however, for the vertical, because initially both were moving horizontally, so they would not have any vertical motion. So what we're going to do is we're going to write 0, because there was no vertical motion before. If it had been, we'd just make vectors and add it. And afterwards it was positive m1 v1 sine theta minus m2 v2 cos alpha. Oh, sine alpha. Okay, please look at it. Let me know. Right. Now, past 2 years, there's basically giving two-dimensional momentum. So I expect that this time they will also give you two-dimensional momentum. So I just want to remind you, it just works like regular vectors, because momentum itself is a vector. But the only thing is now you're multiplying the mass as well. And now remember that for resultant momentum, use the Pythagoras theorem, which means that momentum resultant will be equal to momentum in horizontal direction square plus momentum in vertical direction square root. All right. Please just look at it for a minute. and see if you can ask me any questions. Okay, now let's do a couple of questions, okay? So you guys can actually understand what I mean by this. So we'll open basically a worksheet. So my drive, where is my drive, where is my drive, where is my drive? Okay. Okay. So let's one by one solve these and try to basically figure them out together. And then I will give you a worksheet so you guys can actually attempt some questions as well. Only give me a second, please. Alright, so if you look at this question, you would basically realize that basically we won't do part 1 and 2 because we haven't done it yet, but we'll do this. So it says a leisure park ride consists of carriage that moves along a rail track, and part of the track lies in the vertical plane, follows the arc as you can see. Now it says that for the carriage moving, show that the decrease in kinetic energy is 9.9 times 10 raised to power 4. Okay, we can do that, I think. So at this point it has a velocity of 2 and at this point it has a velocity of 12. So what you're going to do is you're going to do kinetic energy initial is going to be half times 580, that's the mass, times 22 squared. Kinetic energy final is going to be half times 580 times 12 whole squared. Out the calculator, you do so you got 1,40360 joules, and here you got like 41760 joules. So the change in kinetic energy is going to be, subtract them, 98600, which is basically 9.86 times 10 raised to power 4, which rounded to two significant figures would be this, hence shown. Is it clear, everybody? Now then it says calculate the gain in gravitation. Because this is the vertical height it goes, so we're just going to write mgh 580 times 9.81 times the height is 13. Plot the calculator. Oh, 9.81. Show that the length of the track is 20. So they want us to find this track length. Okay, so for a circle, we know that the circumference is equal to 2 pi r, because this is a quarter, so we're going to divide by quarter, so it was going to be half pi r. So half times pi times 13 should give us the answer. Let's try. So that's 20.42, which is for two significant figures shown. Okay, so this is not even the real question. Now it says that you carriage B1 and B2 to calculate the average resistive force acting. Now, technically, the energy that is lost should be gained by gravitational potential energy, but you see there is a difference between these two. So, work done by resistive force should be equal to the difference in the energy, 9.9 times 10 raised to 4 minus 7.4 times 10 raised to 4. So very quickly, this is going to be 2.5 times 10 raised to 4. Now work. Any questions? Please let me know. Aman, Ramin, Med, Aisha, Khatija. Where are you people? Okay, Javeria. Everything is clear, Ahmed?
Yes.
Okay. Now, it says, now this is the question which I was actually doing. Describe the change in direction of linear momentum of carriage as it moves from x and y. Because momentum in this direction, they have already shown it is horizontal. When the carriage basically goes here on y, it will be like this, which means the change is 90 degree. You can also write perpendicular. You can also write horizontal to vertical. Now the reason they're asking this question is because they want you to find the magnitude of change in linear momentum. So first of all, we're going to find the initial momentum. So initial momentum is mass times the velocity, which essentially comes out to be 580 times 22, 12760 Newton seconds. Then the final momentum is 580 times 12. That was the final velocity. That comes out to be 6960 Newton seconds. But the thing is, this is horizontal, this is vertical. Because they're at 90 degrees, so one is like this, one is like this. So the resultant has to be right here. So this is initial momentum, this is final momentum, this is 90 degrees. So we got to find it through the Pythagoras theorem. So what you're going to do, 12760 square plus 6960 square root will give you the resultant momentum. So 12760 square plus 6960 square. So that is 14534.35 actually, but it doesn't really matter because this is going to be 1.5 times 10 raised to 5 Newton seconds. Is it clear, everybody? Any questions? I hope that's clear, right? Now, in the next question, it says define Newton's third law. We already know Newton's third law is basically rate of change of momentum is equal to the resultant force. So this is basically Newton's third law. And now they have given you a question. They say that there is mass mx, mass my. One is stationary, one is not. It's a frictionless surface, and afterwards they stick together. So this is the case 2 that we have already done. If you don't remember it, you can go through the notes, also the recording, please.
Isn't this the second law?
Yeah. Oh, sorry, my bad. Oh my, I thought he's asking for second law. Okay, I should write first law. Say third law. Every action on body A by body B has an equal and opposite reaction on body B by body A. That's the third law. Now, so this is the case 2. You can go back to the recordings, check what we have done. Now, I'm gonna write the conservation momentum equation m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So this is the general equation. So first time it was mx times 5v, and this is my times 0. Now afterwards what happens is that basically when they stick together, so mx plus my should combine and they're moving at a single velocity v. Is it clear, everybody? So your equation becomes mx times 5v equals to mx plus my times v. So you cancel v because it's same on both sides. Now you have 5mx equals to mx plus my. You take mx here, so it is going to be 4mx equals to my. What do we need? My over mx. So you divide it here. So my over mx is equal to 4, shown. If you have any questions, please let me know. Okay, perfect. Now, then says calculate the ratio total kinetic energy of x and y after collision and total kinetic energy of x and y before collision. Now let's check this out. So total kinetic energy after the collision was half times both masses were added because they were combined times v square. Before that, the kinetic energy was half mx v square plus half my 0 square, because my was not moving. This will be half mx plus my times v square divided by half mx v square. So half cancels out, v square cancels out. So you're left with mx plus my over mx, like that. Now it's pretty simple. What you should do is that, you know, from the previous part, my was equivalent to 4mx. So we're gonna replace my with mx plus 4mx over mx. So the upper portion is going to be 5mx over mx. This cancels out, so the ratio is 5. Is it clear, everybody? Please see if you have any questions, let me know. Okay, Aisha, Javeria, Khadija, Ramin.
No, sir, Captain.
Okay.
No, sir.
Okay, good. Now state the value of ratio into for a perfectly elastic collision. For a perfectly elastic collision, the kinetic energy after should be equal to kinetic energy before, so the ratio should be just 1. Do you guys understand? Because if you divide the same kinetic energy after over the same kinetic energy before, so it should give you 1. That's why this is just 1 mark. That's checking your concept. So in 10 minutes when the meeting ends, you guys need to rejoin the same link. Please do remember that. And now let's move to this question. Okay, in fact, I should leave this to you, or should I complete this question? I don't know. Let's complete it with this question, then we'll move forward to this one that's 2-dimensional that I wanted to focus on. Now, it says block X makes contact with block Y at time equals to 20. Describe qualitatively the magnitude and directional resultant force if acting on block X like this. So, if block X basically hits Y, it's going to basically a force of X will be on Y on this side, which means force will be here of Fy, right? So at 20 milliseconds, we're gonna say to the left. Is it clear, everybody? Okay. So the next question, it says from 20 to 40. Okay. Now from like 20 to 40, the resultant force should be wait just a second, but they have given, oh my god, this should be, it says from 0 to 20. From this point they've not hit actually, that should be 0. So basically no direction, no magnitude, because they should hit. From 20 to 40, you see that this line is a constant line, which basically tells you that the force